We can balance it.
Yeah, good morning. Good morning, everyone.
Guys,
Yeah, the class better run. Yeah, let's begin today's class. Okay, can you help me close the door? Thank you. Yeah, because our today class is the first and the second, so we have to get up early, right? So some people will get tired because the last night we have a very fun activity, so in the morning may hard to get up. But yeah, it's okay. No. Yeah. And do you receive my PPT in group?
Yeah.
And the video I have to see because it's so large that I should do something with that. So maybe later. And yeah, you get PPT. I hope that students after class and review it. And because sometimes you may not get a point in the class, but the main thing I just follow this logic in the PPT. So yeah, because now we do not. Yeah, do you borrow this book from the senior brother in campus? No. So I remember I think that the digital version. You also can watch it maybe on phone, computer, on your yeah, right? Yeah, it's not. It's okay, but actually you get one, get the book, textbook, and buy with the PPT, and they will have it will be good. And last weekend I went to Hangzhou to attend a seminar, to communicate with other teachers. Yeah. So I ask you, do you finish the interesting homework? Yeah. The first time. You want to present this class? Next week, holiday. Okay. I mean, what I want to say that because an old saying say that if you have an apple, I have an apple, we exchange. We only have one apple, right? But if you have an idea, I have an idea, we communicate. We will both of us will have two ideas. So I encourage that my students that attend some competition or do the presentation and to show yourself on the ground. On the crowd, right? Yeah, there's to show yourself and to show your idea, and just it's a platform for you, right? Yeah, and be brief. It doesn't matter because now we are just discussing in class and the future in the that you may face lots of people that so grabs the chance and to be truly the true of you. Yeah. So okay, let's come back to our today class. So the first part is about to review what we learned in the previous class, right? And from the last class we know last class we know the load, like permanent load, is for field, normal distribution, and imposed action is for field, the Gaussian distribution. Right? I also mentioned the steel, the yield strength, and the concrete pressure strength. Right? They also fulfill the normal distribution. So, yes. So the question is coming. Who can write a formula? Do you remember a representative formula? Right? The load and the material strength. The formula is different. Yeah, it is a little different. So who can come here to write the formula about the load and the material strength? Because it's all fulfill the normal distribution. Right? Here we only talk about the permanent load and the material strength. Who can come here to write? Just try. It doesn't matter. It's not. Okay, I give you the tips, right? There's a mean value, right? Because it's a statistic analysis, we collect data from the laboratory, and after we do the test, right? There's a lot of data, but we do the statistic analysis. There's two important parameters that we will relate it. One is the mean value. One is the standard deviation, right? So who can try? It doesn't matter. There's only a symbol difference. Other is the same. Okay, do you remember the? Do you remember the normal distribution, right? For load, right? You will choose this value as a representative value, and this is for load, right? And for material, we choose this value, right? Material strength. So this is the mean value. Yeah. No one want to try to write the formula? My question is there's a two formula. Yeah. I want you to write the formula here. It's about to show the represent value. How we get this represent values here? There's a relation. Do you remember? No? Okay, I also give you that. There's a 1.645. Right? There's a formula. Can you just recall some memory about that? I remember I emphasized in the last class that I hope you can remember this two formula. Because I also can feel there's a 95%, right? 95%, because the data we do the test in the laboratory, the values what we get, they have a deviation. They will want be a true, specific the value, right? Yeah. So they fulfill distribution, but we always choose 95%, and this also choose a 95%. But he is a low part. He is the high part, right? High part. So yeah, I write here. I hope everyone can remember, right? the value is a mean. Here is a plus, right? Plus. And there is the minus. Okay? These two formula, that's the things that yeah, okay, look at this figures here. For the load, this is one for the load. They fulfill the normal distribution. And for this represent value, we fulfill this formula, okay? This formula. There is a plus. Yeah, plus. And the reason why we use the plus, because for load, we want this represent value can contain the all condition, not all, 95% condition for the load, this level load. Yes. And for material, right? Yeah, for material, this picture is talk about the concrete, and we choose at the low part this value, and how get this value is this is the mean value and this is the standard value, but they is in the low part. And why we choose this one? Because for the concrete material strength that we want this value just can represent this level's conditions concrete. Yeah. And in the future class, we will talk about the design, right? There you will know that they are all fulfill the normal distribution. This one is the load, right? And this is the material strength. And in here is the 95%. For this one is the load, and this one is the strength. We hope this part, and because we hope, yeah, the buildings and the material do not fail under the load, right? So here we need to make sure the 95% the material can provide strength. So maybe the futures we will talk about. In this part means the load is larger than the strength. So this is the failure possibility. Okay, but in other part, the strength always larger than the load. So the structure will be the same, right? So here is a future. In the future, we will see. But now, I want you to remember how we get this represent the values. Okay? Yeah. I repeat it again. So in the future and in the next class, if I ask you the same question again, I hope students be brief, and come here to get the right formula for us. Do you have a problem? No. Okay. And in the previous class, I also mentioned the concrete, right? The mechanical property of the concrete. I remember I introduced three very important strengths. Yeah, do you remember what it is? Yeah, so you want to say something? tensile strength. Compression. Compression strength. There's a two concrete compressive strength. Do you remember? Cubic. Cubic one. Cubic is one. And what else?
Prism.
Prism. Who said that?
Water.
Okay. You are the 大卫，莫有，Wenchi, you need to be brave and see something. Moyo and do a really good job. And he now gets 2 points. 2 points in my list. Very well.
Moyo is smart.
Dawei gets 0.5. Okay. And Chujiang also gets 0.5. And Jingya also gets 0.5. And Wenqi is 0. Keli also no. And Ziqiao gets 1 point. And every student answer the questions in my class. I will do a remark, and you can also come here to take photo and monitor my behavior, because this point, this score will count in your final exam. Okay? I stay at here. So I encourage the students here. Just because in the class we discuss, right? We just discuss. That means if you answer the wrong, but if they had the possibility that you answer is correct, in practice you can get the point against the scores. So after class I encourage students to do some review about the things what we learn. And just skip it really quickly, and I think you can get something. Ziqiao answer is very well, and talk about three strengths. One is cubic compressive strength. Do you remember I showed you a video, and the guys to do the test, and they give us the process how, because for the cubic compressive strength, it's related to lots of factors like humidity, temperature, and because of different ingredients, right? And the proportion of the water, cement, and the gravel aggregate. So he need have a standard process to do the test and to get it measure it, and then we get this value has a meaning, right? It can compare with others with other place the concrete strings. So one is a cubic, and another is a prism compressive strength. I just see a little things about that, because today this class we will learn. And another is the tensile strength for concrete. They under the compression, and sometimes they will under the tension. But the tension strength, they have the we compare these three strengths. The biggest one is the cubic. Remember, the cubic compressive strength is the largest among these three strengths. The next is the prism compressive strength. And the last one is the tensile strength, because the concrete is weak in tensile. It's weak in tensile. Look at these figures, okay? These three strengths we needed to remember. And for cubic, I emphasize that here, he only for us to classify the concrete grid of the concrete, right? For us, just to compare. And for the prism compressive strength, here, because we do concrete design, concrete structure design, we will use this strength. And for the tensile strength here, I will not say something about it, but here, these two, we need to distinguish, right? Yeah. I asked to, does any student have a question? No? Yeah. Here, these three strengths, we need to remember, okay? And I also see the difference. And for cubic compressive strength, we always, in the video, we remember there's a standard specimen, right? And for the size, it's 150. The sheet will look like this. And for this is standard size, the cubic condition may list here a little different with the video, but it doesn't matter because in China I capture this information from the Chinese code, and in video is Indian code, and it is 27. Yeah, the Celsius really, and other place maybe. But for here, we only need to remember there has a standard temperature and also the humidity. Yeah, and here's we talk about the reason why the prism compressive strength is a little smaller than the cubic compressive strength. Right? For cubic, because the compression test machine, the surface touch with the specimen, right? For this side specimen, the friction will affect about the cubic. And if we give some oil to smooth, to smooth the machine, the failure node will be like this. So the friction will affect greater with the size. And the conclusion, what we need here is the cubic compressive strength cannot reflect actual stress state because it's affected by friction, right? Friction. And it's only the standard, how different the material, the grid, the concrete, the different grade of the concrete, they compared in the cubic sheet, right, under the compression machine test. And it's only the standard to compare the strength and the quality of the concrete under the same standard condition. So the meaning of the cubic compressive strength that we do the test, we get this value, and only to compare. Because the same sheet cubic specimen, they suffer the same friction. So in different the grade of the concrete, they can compare at the standard size, standard level. Right. So here I talk about the why cubic larger than the prism, and also for the cubic, it's affected by friction by the size. And for the size defect, I remember that we use the conversion coefficient to make it, to transfer it to compare. Right? For the larger size, the depth, the value we get from the laboratory, we need to multiply this conversion coefficient. And for the smaller specimen, the value what we get, we need to multiply this coefficient. And in American Japan, they do not use the cubic, they use the cylinder, standard specimen. And for the size, the diameters, they are listed here, just to let you to take the reference. That's the difference between different countries. And then also some scientists and the engineer, they do lots of tests and build the relation, right, of for the cylinder specimen with the cubic specimen. The value around is 0.79 to 0.81. Yeah, and for in this part, we see something about the cubic compressive strength. And here, I want to see the student have questions or not. To see this part about the cubic compressive strength. No problem. Yeah. We will go to prism compressive strength. Yeah, and there is another thing. Is when we get the cubic compressive strength, right? Yeah, they may on 50 level, 20, 25, 30, yeah, and to the 80, right? 80. Yeah. And for here, there is a critical values for us to judge. For the concrete cubic compressive strength is less than the C50. We see the normal strength concrete. Normal strength concrete. And for the concrete, the cubic compressive strength is larger than the 50. We need this type of concrete is the high strength concrete. And later we will use this concept. Okay? We will use this concept. Yeah, also here there's no less than 95%. So that's the reason why we choose in the low part. And okay, in the next section, we will talk about prism compressive strength. Okay? Yeah. For the prism compressive strength, what we know now is this specimen under the compression test machine, the compressive strength is smaller than cubic. Cubic because it's not affected by friction. Yes. Okay. Because for the prism strength, yeah, this size, the B, and for the H is the height, the Y and the height, there is about 3 times relation. Okay, for cubic, the Y, the height is 1 divided 1. But for the prism, the specimen, what we get here is the height is 3 times than Y. Okay. my student can give some response. Here, we just in this view, but exactly it's the height is 3 times than the width. The friction may affect this part, and in the middle part, for this concrete is not affected by the friction. Look at here, friction has a great effect. This part, in the middle part, the friction has a smaller effect, closer, because in this part, this middle section, it's close to the actual, unit axial stress detail concrete. So for this part, the value what we get is close to the real, the actual the stress detail. That's the reason why we use this compressive strength in the structure design, right? Yeah. Yeah. Can you imagine? Yeah, this is the machine, right? This one is a touched machine, and this is also a touched machine, and give it the compression. Prism compressive stress is lower, because it's a less friction effect. So
okay. So maybe the comparison of, in other ways, the difference between this compressive strength of the prism and the cubic, the only factor that determines their strength is based on the friction effect.
That you want to know the only difference about the size of the specimen?
No, like, I mean, right, isn't it like we're looking at the, yes, for now, the prism compressive strength and the cubic, right?
Yeah.
So I'm saying, so the only factor that determines their strength is only based on the friction effects.
Yeah, because of the friction effect. Because look at these figures, okay? Yeah, because the machine they touched in this surface, they will give the effect about friction, right? Friction. Look at here. If you give it compression, exactly, it will. There's no friction. The failure will look like this. The crack will develop in the vertical. But of the friction machine, because in here you know that like one thing we touch this surface, the surface will give it the force in this surface. Yeah? So we give the compression, the crack develop to look like this. They will do not develop in the vertical. Yeah. So here we named all of this phenomenon, this effect, named it the friction effect. Yeah, friction effect. And look at here. For the prism, the specimen, we do it here. This surface, of course, it will affect it, right? The stress, the force, it's just like a wave. They will transfer. They will come. And here in the middle part, we do not see it. There is no friction effect, but compared with this part and this part, we compared this part, it's less affected by the friction. Yeah. So So that's the reason why we do the test and get the prism compressive force stress values is less than the cubic. Yeah. And the specimen's standard size is I list here. Yeah. And the height is 450. It's 3 times than the width. Yeah. So it's okay?
Yeah.
Okay. Yeah, if you have the question, we can discuss the after class. Yeah. Thank you. Think brief. Yeah. To just ask the questions, right? Yeah, usually be the 3.0. Yeah, and look at here. This is the the engineer did do the prism compression test, right? Or we get this specimen under the machine. And yeah, also some other countries like Japan, they use the cylinder. Yeah, and look at here. Here's there's the 2 types. Okay, you see.
Can I take this one?
Okay.
Yes, sir.
Here's where? This one?
Yeah. So this is this like the cylinder and that one.
Yeah, cylinder. What's wrong?
Oh, okay, I see. It's okay.
It's okay?
Yeah, it's okay.
Okay. Yeah, and right? Before I mentioned the grade of the 50 is the normal concrete, right? And therefore it's the higher strength concrete, normal strength concrete. And because here people do a lot of tests and get the value, they build the prism compressive strength with the relation with the cubic compressive strength, right? But the coefficient they found the difference is the normal strength concrete. This is the linear formula, right? For this one is the cubic, this one is the specimen. They have a relationship from these figures, right? These figures. Yeah, and the coefficient K here, because we know the prism compressive strength is less than cubic. So this coefficient must smaller than 1 point, right? 1 point, and then they multiply. Yeah, this one. They the scientists they do the test. They collect the value and build this relationship. And for the normal stress concrete, the coefficient K is 0.76, and for the high stress concrete, K is 0.8, around 8. So this figure just to let you know, and the cubic compressive stress and the prism compressive strength, they had a relation. They around 0.7 to 0.8. This range types relations. Okay. These figures is we get from the laboratory. We do a lot of experiments. like the spaceman, and the text, they on the theme, ingredient, proportion, and anything in the theme, and they just text the strength and build this relationship. Okay, take a rest.